Welcome to Easy Math TV. This is a walkthrough of our second lab in our Statistics for Life Sciences course. And we're only going to be doing exercises 1 to 3 on this lab. There is stuff that comes after that. And I don't want anybody to feel like they need to do that. So basically we're just going to be doing exercises 1 through 3 on our second lab called Introduction to Data. So on the posit.cloud resource that I gave everybody, that's basically, this is my Posit Cloud account, and on it we see basically, if I click on project, this is everything that we have for our labs. Most of these folders you're not going to need. There's a lot of background information here, but this is the site that you load when you click on that, or when you load the link that I gave you in your browser. And our first lab was Intro to R, so you can actually see the folder there. This lab is Intro to Data, so click on that. And there is an actual file there that I've saved that is basically going to be, I'm going to use this for the walkthrough here. And that's actually showing up here in the files area, because I'm just going to be copying and pasting from that because it just makes it easier to get through the video. The instructions for the lab are the introtodata.html file. Feel free to open that in a browser window. I would suggest that you actually read through that a little bit, read through the top section of it that starts with the introduction to the data set we're going to be looking at, where it says getting started, and then just kind of read through what it actually has you doing all the way down to exercise 3. Just kind of read it over before you actually view this video, okay? All right, so let's just go ahead and load the data. We're going to type or copy and paste this, and when I hit enter, you should see a data set appear up in our environment window up here in the upper right of our Posit Cloud. So you're going to be doing this in your own Posit Cloud account, where you are going to have probably just an empty files directory. Why don't you click on the tab for plots, because we are going to be making a few plots. So go ahead and have that visible. And the environment should now show CDC, which is Centers for Disease Control. And feel free to click on the expand arrow in front of it, just so you can actually see the list of all the variables that are given there. Okay, those are the variables. If you don't want to just rely on that, like, we can type names, parentheses, CDC over here in the console. Names, parentheses, CDC, that's going to give you all of your variable names. So those are your 9 variable names. I'm going to let you kind of, we're just going to look at a couple of them. Let's type, and this is different than what's in the directions for the lab, so just follow along with what I'm doing here. Type unique, parenthesis, CDC, $smoke 100, and that's our first, that's just one of the data types that we're looking at here. And unique is going to tell you what are all the different unique responses to the question. So under the question of smoke 100, the answer is either yes or no. So basically no was probably 0 and 1 is probably yes. All right, but those are 2 numbers, and those are the only responses that you're going to see in that column. We can do that for all the variables, but let's just do it for a couple of the interesting ones. Let's get unique. Let's type unique for the weight variable. So unique, parenthesis, CDC, $weight. And for that, you can see that there's a lot more of a variety of responses. And I'm leaving it up to you to decide whether that is a discrete or continuous variable. You have to decide whether that's discrete or continuous. And you're just looking at the numbers as they are. Weight itself, in general, like when you have things that are measured by weight, obviously numbers that have decimal values in them are definitely going to be continuous. But you have to decide for this one whether we're going to be treating this as discrete or continuous. And then let's just do one more. Let's see what the unique values are for the gen health. And for that, we see that there are text responses. So it was probably people were given options. So the options were either good, very good, excellent, fair, or poor. So you had 5 values there. And actually, if we go over here to the environment, we can see that there's basically 3 different unique styles, or 3 different data types that are identified in R. In R, we have num, which is basically, those are the ones that are just 0 or 1. And then we have factor, which basically the responses were like categorical variables. And then we had these 3 that are type int. So the weight, and then the weight, desire, and height. Sorry, age, weight, desire, and weight were type int. And then height was also, for some reason, a num type. So that's just interesting that R designates them that way. But your job is going to be to report for exercise 1. You have to answer what are the 9 variables and what are their types. So for each one, you have to tell me whether it's categorical. And if it's categorical, I want you to tell me whether it's ordinal. Is it an ordinal categorical variable? And then under the numeric types, I just want you to tell me whether it's discrete or continuous. All right? So that's what I want you to tell me there. We can answer the question of how big is this data set? We can actually look and see just how many of the responses are present here. And so I just typed the length. I just typed the command length, and you can pick any of your CDC $ variables there to get the length. They should all be 20,000. So no matter what variable you pick, there should be 20,000 values for that random variable. Okay, and then let's expand this a little bit. So I want to also show you right now how can you just take a look at how the data is organized. If you want to know how the data is organized, you use the commands head and tail. So head parentheses CDC and tail parentheses CDC. That's going to give us the first 6 rows and the last 6 rows of the data. Because with 20,000 values, we don't want to print out all 20,000. So this is just giving us a kind of a picture, a snapshot of what the data might look like if we were looking at it in a spreadsheet. So you've got your top 6 rows and your bottom 6 rows. And for each person who was surveyed, we collected these 9 pieces of information from them. All right. So what I want to just do quickly here is just go over how do you what is involved in a summary of a certain data value. So if you just wanted to summarize one of the variables and give summary information about that, what would you need to do? So this is basically related to exercise 2. It wants you to do a numerical summary, and it also wants you to do a summary of 2 of the categorical random variables as well. So we're going to start with, what does a numerical summary look like for weight? And whatever we do for weight, I want you to repeat this for the height and the age. Okay, so you're just going to repeat these commands. The first 5 are just some numbers that we're going to calculate. We're going to get the summary, the mean, the standard deviation, and the interquartile range. So basically, I'm just going to highlight all 4 of those commands and copy and paste them down below. Okay, and this is going to give us what we call summary statistics of a numeric random variable, or a numeric variable. So the first thing I want you to call your attention to is we have the minimum value. So that's your 5-number summary here. The minimum, the first quartile, the median, the third quartile, and the max. And stuck in the middle there is also the mean. But the 5-number summary is the min, the first quartile, the median, the third quartile, and the max. Okay? And so that's that. And then there's a bunch of commands. Actually, let's make this 8. And I'm going to add here a box plot. So we're also going to make a box plot of our data as well. So where it says, this is, let's do box plot. Nope, I don't want to erase. I just want to put a box plot. And CDC $sign weight. Okay. All right, so back up here. So before we do those, so you've got your min, first quartile, median, third quartile, max. So that tells you just kind of how your data is spread out. You've got your minimum value of 68, your maximum value of 500, and then how are they kind of arranged in between that? Like where's the middle 50% of your data and so on. Visualizing that will be much more helpful, I think. And then we've calculated our mean, so you can report that as 169.683. The standard deviation is 40.08097. Do not do any rounding, just report them exactly as you see them here. And then the interquartile range is 50. So I want you to actually identify these as the mean, the standard deviation, and the interquartile range without using like these little abbreviations here. Okay, so those are called summary statistics of our variable weight. But much more helpful will be the actual the frequency table. So we're going to make a frequency table, and it's going to be a binned frequency table. And then we're going to make a histogram and a box plot. So let's see what that looks like. Again, there's like 4. So these are 4 commands that I just copied and pasted. And so when you do this lab yourself, you're going to be replacing weight with height, and in all of these. So wherever you see weight, you're going to replace them with height. And then wherever and then you're going to do it again by replacing height with age. So everything that you see here will stay the same, except for the where you see weight will become height, and where you see age, where you see height will then become age. Okay, so let's hit enter. All righty. So it looks like there are quite a few outliers in the upper end of our data. Quite a few outliers. And there's our histogram there. So what I want to point out about the frequency table, what you see here in the frequency table is these are our binned categories. But instead of telling you what the lower limit and the upper limit of them are, it's just telling you what the midpoints are. If you want the lower limit and the upper limit, you're going to have to look at the histogram to get that. So, for example, that first category, the first class has a midpoint of 75, but it's all the numbers between 50 and 100. So it starts at 50 and it goes up to, but not including 100. Okay, the midpoint of that is 75. And then the next category or class has a midpoint or middle value of 125. So if you go over here to the histogram, we have a column that goes all the way up to 7,221, but it starts at 100 and it ends at 150. So these are all 50 apart from each other, okay? So you've got the midpoints of each class, and then you've got the counts, the actual frequencies for each class. And then you have frequency density is the relative frequency. So like the relative frequencies are the proportions. These are the proportions within each class, all right? Anyway, that's for the weights. You're going to come up with the same kind of thing, but repeat the same process, but do it with heights. So again, up here, in wherever you see weight, you're just going to change that to height, okay? Leave everything else the way you see it. Like this thing will not change at all. That's going to stay the way it is. But wherever you see the word weight, you're going to just change that to height. And create your output for your lab assignment. Once you create your output, then you can change all of the weight variables to, or the height variables, change those to age, okay? So that gives you an idea of how do you summarize numeric data. So you can actually comment on whether these numbers seem to be symmetric or not. Like you can actually comment on that. Okay. Let's look at how do you summarize categorical data. So the way you summarize categorical data is these 5 commands that you see here. We're going to make a frequency table. We're going to make a relative frequency table. We're going to make a bar plot this time. So a bar plot is your way of plotting your data. And then we're going to save the table that we make in up here. We're going to call it smoke. So we're actually going to save that, and we're going to make a bar plot of that as well. So let's see what these different things actually do. So I'm going to Control C for copy. And so this is for the smoking day, like whether you smoke or not. You're going to be repeating these 5 commands for gender and then for whether people exercise or not, okay? So, same thing. You're just going to do it for those 2 variables instead. So we're doing it for smoke 100. You're going to be doing it for the variable X or any, so exercise, and you're going to do it for the gender data, okay? Let's hit enter. Okay. So the first plot just shows you, this is a bar plot of frequencies, and we just basically, we got the same plot both times, but we actually saved our table as, we just called it smoke because we were doing smoking. And what I want you to see, that we see our output over here on the left. What kind of output did we actually get? We got the output for the frequency counts, and then also the relative frequencies, which are the proportions. So the proportion of people that sorry, that's down here. These are the counts of people that didn't smoke versus smoke, and then the counts, and then the frequencies, so the proportions. So basically about 52.8% of all the people in the survey do not smoke, and then 47.2% do smoke. So that's the approximate percentages there. So those are your relative frequencies. All right. So we also turned that into a bar plot so that we could actually see what the bar plot looked like. And that's how you summarize categorical data. Just when as an individual data value, how would you categorize it or summarize it? The last thing we're going to do is we're going to create a mosaic plot that compares gender to smoking. So we want to kind of see how those line up with each other. So I'm going to copy these two lines of code, and again, we're making a mosaic plot of gender over smoking, just to see how those things line up. So I copied and pasted, and there's your mosaic plot. That it's a perfect rectangle because that's 100% of the data, but it shows us how the data gets split up into smoking on the left. So the values on the left are 0 and 1. So that's your smoking no versus smoking yes, and then male and female. Okay, and there's a question you need to answer based on that as well. So you've got all your plots here that you can basically copy and paste into your report that you make. And then any of your frequency tables, so any of the output that occurred over here that's in black, you're going to want to include that whole thing. So basically, this is the console, and it shows you everything that I typed in, which means we can just highlight that entire thing and just copy and paste. All right. But again, like yours is going to be a little longer than this because you're not going to be doing the smoking data. You're going to be doing the variables that are requested in the lab. But this just shows you exactly what the commands are that we're going to be using and what kind of responses do we actually get for that. Okay. Like, subscribe, comment down below if you're finding these videos helpful. That is your walkthrough of the second lab for statistics for life sciences.